Hi, this is Chong Kim. Welcome to Ruby Chess version 3, part 3. Okay, so let's take a look to see where we were. Okay, so we had a problem with the knight CE5, and somehow this knight was not being recognized as a possible move, so this wasn't there. So when I looked through this code, I discovered that the problem was in the copy. Oops. Let's go to the code. Okay. The problem is with pieces because pieces is set up as a hash, and the hash contains a set. So it contains a set like this. So when we make a dupe, the hash is duplicated, but the set is actually pointing to the old set. So this is not a true copy. So what we have to do is we have to go through each one of these items and make a dupe of these, and then everything will be fine. So this was actually a pretty tricky bug because it looks like I'm doing everything properly because I'm duplicating the hash, but it's not doing a deep copy. And this is one of the reasons why I like functional programming, because when you change state like that, there's all sorts of side effects that affect your code, and it's not obvious where those changes are. So for this, let's see. We duplicate it, and then we're going to go through each one and make a copy. So at pieces, each, for each of these key value pairs, we're going to return back a key with the value duped. So this is a list. And we can actually make a hash out of this. So this creates a new hash. And as a matter of fact, instead of pieces here, we can just say other. Other pieces, and we copy this. So we don't need this anymore. All right, so this would do a deep copy and create a new hash at the same time. So let's see if that error goes away. All right, same problem. And let's see, other pieces. Oh, I said each here, but it should be map. Okay, it looks good. It's about halfway through, and it finished. So that ended up being the problem. And while this is in a good state, let's do some refactoring. Let's take a look at some of the messy part of the code, and let's take a look at this section of code. This is a pretty long section of code, and what we see here is that we move a piece. Well, actually, we move it with a false, meaning that we don't we do a dry run. We don't actually move the piece. We just check to see if we can move the piece, and we filter the results through that, and then those results would actually be made to move. So we make a temporary copy of it, and we move the piece over here. So we can probably combine these two together. So because this is not necessary, because um, we could do the check right here. So let's see, let's get rid of this, and okay, and let's see, so let's make a temporary copy. Let's see, this is okay, so let's make a dupe of this, and okay, so we make a duplicate, we move the piece. Actually, this time we actually do move the piece, and we take a look at the king result. And for the, okay, so let's see. And for now, we can assume that there's going to be a king. So let's just assume that. And if it isn't, then we'll fix up the code so that it does. And so we'll take the first king. And we can just say, so if we assume that it's going to exist, then actually, so once we made the move, we don't have to check for the king because we've already made the move. So we don't need this anymore. Okay, we don't need to do because we've already duplicated it. We don't need to make the move because we already did it. Okay, and now we can check to see if the king's been attacked. As a matter of fact, actually this piece of code should really be from the temp pieces. Okay, so look, this looks pretty good. And as a matter of fact, we don't really need the king index. We can probably just take this whole thing and put it right in here. Okay, and get rid of that. All right, let's do this. And we only want this thing to happen if this succeeded, because this could possibly return a nil. So I'll wrap this up and put an AND in here and join these two together, and we don't need to have this false. So we've reduced this down quite a bit. So let's take a look. We get a temp and we see if it's attacked, and based on these pieces. Okay, so let's see if this works. So far so good. Okay, so this works fine, and using the same trick, we can probably use it somewhere else if we have similar code. Okay, so doesn't look like it. Okay, so one other thing that I realized too is that I thought that attacked would probably come in more in use, but the only reason why you would need attacked is for check. So actually, let's define in check, and this will actually do everything that this is doing. See, attacked. Okay, so take this whole thing and we'll put it right here, and we'll just say temp.in check. Okay, so let's see what this in check would look like. Well, you have the king. Okay, so let's see if this compiles. All right, so there's some issues here probably with parentheses. Let's see if we have everything. Okay, the parentheses on this, actually this attack is missing, so this probably needs an extra parentheses here. Okay, so in check. All right, and this one doesn't need it, and we can just close this up. Okay, so let's see. All right, so undefined local variable or method temp. This is in check in 193, so right here. So temp. So for this, we don't actually need the temp because we're calling it, we're actually checking to see for the current object. So we don't need temp in there at all. So let's see if this works. Undefined local variable temp again. So there's another temp right there. And this one could just be at. Okay, so far so good. This takes 10 seconds. It's not bad. All right, so in check. As a matter of fact, we can probably turn off the printing because that was really to make sure everything else is going right. But all we want to do is check to see if actually we can join these together and just go like that. And we'll just comment out this line. So now it should compile, run a little bit faster. Okay. So let's see, run this again. Okay, so that took about 3 seconds. Not bad. Okay, so let's take a look at this and try to see if there's we can take this whole thing. Let's see where attacked is being used. It's only being used for in check, so we can just take this whole thing and just put it right in here and replace all this stuff. So let's see what opponents. Okay, and color, if the color is black, so we can, let's see, if the turn is black, actually if the turn is white, then if the turn is white, then you want to downcase it. Okay. All right. Do you need anything else? It needs to find the king index. So that's the 2. So let's look for the 2. And there are 2 places, and 2 is equal to, actually let's call this king index. So okay, change it to king index, and that is just pieces. Okay, based on the turn, it's either going to be a capital K or a lowercase k, and we take the first one. Okay, let's see if this still runs. Undefined method attacked. Okay, so let's see where attacked is being used. Oh, it's not in here, it's in the test. Okay, so we don't need these anymore. Okay, illegal move for the first one. Okay, so okay, in check. Okay. All right, so let's see. Okay. So illegal move e4. So why is, okay, let's see. The king index is the white king, and it's white's turn, so you want your opponents to be downcased. And you're looking for all the valid captures from to the king. Okay. All right. So let's take a look at the first condition, the move. All right, let's put a debugging statement in there. Okay, so we tap this and put a debugger. All right, let's step through, see where it's going wrong. Okay, move. Okay, display list. Okay, it's empty right now. And okay, so we have a list of potential moves here. Select based on the column, the row, and now it's going to, oh, I said if it is in check, it's supposed to be it's not in check. So I had the logic reversed. Okay, so we can just take this out and go back, and let's go to the logic, and it's not in check. Okay, so let's see. Okay, 3 seconds. That's not bad. Okay, so the other thing that I had a problem with was with set. So set is like a list, except that it keeps it has to keep its elements, its members, sorted so that it can make sure that there's no duplicates. And that's a little bit of an overhead. And I think it's probably too much of an overhead. So what I'm going to do is I'm just going to get rid of set and just use list. Because the only time that we need to really test that we need it sorted is when we compare it. So let's just get rid of it. And we have these tests, so I don't feel actually, we don't even need these because all the pieces are set, so we don't have to default them because they already exist. They should exist. Okay, so we got all the sets, and we need to get the add. So let's, okay, so add is going to be changed to push. Okay, and let's see here. Okay, so there's, and then change that to push. Okay, done. All right, so we have a comparison that's wrong. So this is what I expected, because the whole purpose of having a set is because of the comparison. When we compare the pieces together, the order shouldn't matter, but in this case, the order does matter. So right before we do this, I'll sort it. So pieces sort. Actually, we don't sort this because it's a hash. So each one we sort. So we have the key value, and we want the key to, we actually want to have the v sorted. So sort. Okay, so this is actually going to be changing the list. Okay, and then we also want this to be done with the other as well. So other pieces. I'm not too worried about this because the only time that we're using this this comparison is when we're in our tests, not in the actual running of the code. So other pieces, each, and kv and v dot sort with an exclamation point. So this way it changes it. So let's see if this fixes it. Okay, this is good. And let's change the output of this so that this prints out the pawns, because it's saying that it's an illegal move for the pawn. So let's run the ctags because it's been a while. Oops, ctags. Okay, and let's go to 2s. Okay, and over here we're just printing out for the end, but let's print it out for the pawns. Okay, so we see that the pawn list is empty, so something got really screwed up. And let's see. Actually, I looked at this bug before when I was practicing this, and the problem actually ended up being right here. When you move a piece, normally when it was a set, 2A would create a new set, which is a list. Actually, not a new set, a new list. So it'll take a set and convert that into a list, so you get a copy. But because this is already a list, 2A does nothing. It just returns the original list back, and so it doesn't actually do a copy. So in this case, what we really needed to do was dupe. And so let's take a look. Okay, and much faster. So we see that with just a few changes, it went down from 3 seconds to 1.377 seconds, and that's to run through the whole file. So that's not bad. Okay, so so now that we have this thing done, let's work on some new features. The first feature that we're going to add is possible moves. So let's take a look to see how that would work. So in our tests, let's create a new one. Since it's pretty fast, we'll keep this around. If this was really slow, I would comment this out and only run this occasionally, but because it runs in 1 second, we can afford to have it run all the time. All right, so we have the context, and we're going to be testing possible moves. Okay, so let's have possible moves run in two different modes. One is it could run without parameters or with a parameter. So let's just say, for example, okay, let's set this up. So we have a new position, and we ask for possible moves of, we give a square, the from square, and let's say it's G1. So there's a knight on G1. So we expect that the subject is going to be equal to, there are two squares where the knight can go. It can either go to F3 or H3. So those are the only two squares for this knight. So this is what we expect. So let's get this working. Okay, undefined method, possible moves. So let's create possible moves and give it a piece. I'll just say P. And actually, it's not a piece. It's the from. So from this point, where can you go? So let's see. We have move piece, which does the mechanics of it without fully looking at the legality of that move. So possible moves. So we have indices. So let's go through each one of those, and that will be our 2. And we'll make a move from 2, and we'll start off with a list, an empty list, and we'll return that list. So move piece, okay, so let's just say this is, we can't just move piece, we have to do it on a temp. Okay, so temp is equal, okay, we'll just do a dupe move piece. And we have to see if, there's a few checks that we need to do. Actually, let's see what move piece checks to see if the path is clear. So the only thing that we need to do is make sure that you're not in check. So okay, so we had this before, which is we do that and we test the temp. So actually not temp in check. Okay. All right. So you make a move, but your king is not going to be exposed to check. Okay. So if this is true, so we put this as an if, then we can see. Actually, we have the from, so we have the 2. Okay. Actually, I was just looking at possible moves, and if we're going to have possible moves and to list all the possible moves, then we really should have it looking like this. G1 can go to F3, and G1 can go to H3. Because when we have the full possible moves, we want to have it from all positions of from and to. Okay. Okay, so let's go back. All right. So it's going to have a from and to. like this. Okay. And let's see. Go through each one. Okay, so this looks pretty good. And let's see if this passes. Yeah, it's got an empty list. Oh, that's because I'm not storing this anywhere. So list that push. All right, so let's see if this works. Okay, this passes. So now we can do the next part, which is so I'll just put the context here as for a square. Okay, and see. Actually, this is sort of slowing me down. So I think I'll put this at the end. Okay. Because I still want it to run, but if it fails, I want it to fail quickly. Okay, good sign. All right. So let's go back. And, oh, actually, we were going to write the test. Okay, so we need a new context. So all possible moves. Okay, so if you start with a new position, actually, dot possible moves, then I expect it to include E2 to E4. I wonder if I could say subset. Because I want to give a bunch of these things. So let me just see if this works. If not, then I'll just have to go back to the other way. Okay, wrong number of arguments, and then we have to pass this in as nil, and this way we have to do a test. If there is a from, then we do this. Otherwise, we'll go in here, which will go through all the possible opponents. So I wonder if I have opponents. Okay. And actually, where is opponents located? Oh, it's just this. Interesting. If the turn is white, opponents, and let's make opponents into its own little thing. Okay, opponents, and we'll have this logic here. And this way, and we'll change this to results and return results. Okay, so this way we'll have access to opponents. Okay, that's the king position, opponent, valid capture from, and it's clear path. Okay, I wonder if it fits in here. No. Okay, so let's see. Oh, I probably have missing a parentheses or something. Probably in the new code. Oh, because I'm not done yet. Okay, so we have the opponents, and we're going to go through each one. Actually, since I'm having a list, let's see. Huh. Oh, okay. And okay, let's see. This is just one. This is interesting because I could probably just put some brackets around this, and this is only one if condition, so I can just do it like this. Just bring this up. So it's just one line. And okay, I don't know if this is such a good thing. We'll just keep it like this. Okay, so for each opponent, we have the opponent. We're gonna call possible moves on it. Well, we have to find them. Oh, actually, that means that we have to go through the pieces. The pieces of the opponent, we could do each on those, and that will give us the from. And we call possible moves from that. This will give us a list, and we'll just actually we can do a flat map on it. And for the opponents, we'll also do a flat map. Oh, so this just becomes just an embedded statement like this. Yeah, this could only, it's just one line of one line. I wonder if it, I don't really know if I really like it like this. I think I want to break it up because it's hard to, it's one of those functions that's sort of on the borderline where it seems like it could fit on one line and be read easily, but I find it a little bit too long and a little bit hard to read, so just break it down by one. Okay, so we have the two conditions. We're going to have the possible, we know how to get a possible move for one piece, well, one location, and now we're going to go through all the opponent pieces and see, actually, is it the opponent pieces, possible moves? No, oh, this is not right. Okay, so this is actually going to be, you want your own pieces. So I need to change this. So instead of opponents, it should be, let's call it a piece list. And we'll give it a color. So we'll just say if color is the opposite, so black, then this should be results. And actually, we can just do that so and get rid of this assignment statement. So we're going to run a down case on it if the color is black, and then we just return the results. So we just ask for the piece list. So here we could say piece list of the opponent's color. So we can say if it's white, based on a turn, it's going to be black, otherwise white. And that'll be the opponent. So this piece list, okay, so this doesn't read as well, but it uses this general function pretty well. Give me the piece list of the other guy's color. Okay, so now we can reuse that. So going back here, instead of opponents, we call it the piece list of the turn. Okay, and we'll call this P. And let me see, piece list of the piece, and we flat map it against this. All right, I think this looks good. Yeah, subset. I was kind of thinking there probably isn't a subset. Okay. All right, so let's try include. Actually, all right. I wonder actually if this will work. No. Okay, so let's go back to include and take out one of these things. Okay, so we have to do it individually. All right. Expected bracket to include, oh, possible moves returned an empty list. Oh, the reason why is because we're not actually assigning it to list, so this is what we want. As a matter of fact, it just needs to return it because it's just one thing. And this one, we can just have it inside. Okay. Okay. Flat map. You know, we could probably have this as a flat map as well. So let's see if we can turn this into a flat map. So if this could also be a return. Get rid of this list here and somehow convert it. So depending on this, okay, all right. So it's either gonna, okay. So let's see. If it's from return indices, we'll call this a flat map. We have the 2, and we have a test here. And if this is true, then we want to say from 2, which it's a flat map, so we'll just put it as a list of a list. Actually, this is one item. Okay, so let's it'll do a flat map, so it'll include this. Otherwise, it's going to be empty. Okay. Let's see if this looks right. Let's see. Okay, it passed. So this looks good. So we could just have one return over here. Factor out the return. And because of this if, we can just turn that into a question mark and take away this, and we have that. And otherwise, we have this. So let's see if this works. Unexpected keyword end, so we have an extra end in here. Huh. Okay, so this works as well. All right, so I don't know if this is a good thing, but if there is a from, let me just try to make this a little bit easier. So okay, and okay. Okay, so I think I'll just leave it like this because if it looks really complicated because it's pretty dense in 2 lines, but if I just read it straight, to me it reads a little, it flows a little bit. Like it says, if there is a from, then starting with the indices, do a flat map. So basically you're going to gather all of these together into one list. We have this, we move the piece and we see if it's not in check. And if it is, then we're just going to gather all the from twos. Otherwise, it's just going to be an empty list. So when you gather these together, it'll be the full list. And otherwise, if the from doesn't exist, then you get the piece list based on the turn. Then you do a flat map, which means you're going to gather all these together. You start with the pieces and you do a flat map. So that's just a starting point so that you can get the from. Then find all the possible moves that starts from this location. So it's a little bit dense. It's probably a little bit, I think it's probably good this way, because even if you break it down, it's not that much easier to read. So I'll just leave it like this. Okay, so this isn't bad. So we have possible moves. So because we have possible moves, that means that we can have a chess program that can actually play some moves. All right, so let's take a look at the code and see if we missed out anything. Okay, actually there is one thing that we did miss out, and it's kind of subtle, but I was looking through this code and I was looking at castling. Okay, so here you see you have valid piece movement, and the piece movement also includes a castling position because it allows the king to move 2 squares. But you can only move 2 squares if here's the section where if the piece is a king and it moves 2 squares to the side, then you're going to do a castle. But you want to abort this if uh, if you're about to castle, but you're not allowed to castle because of the castling flag. So you have to check the castling flag. Let's see. We can probably do that above this location right here. So it should be pretty simple. So the conditions are if the piece is a king and well, there's actually two different, there are multiple choices. There are the case where you're castling king side or queen side and you have to take account for which color piece you're working on. So if the piece is a king and let's just put this as see, and you're castling. So I'll just say 2 minus from absolute is equal to 2. Then okay, so then we can clean this up later. Okay, before we do this, we should really write a test. So let's write a test. This should be for the piece move. Okay, so it should be a king move right here. All right, so you start off with a king on e1 and a rook on h1. So you have a situation where castling, you have queen, king, queen here. So this is with, so you're not allowed to castle on the king side for white, and we're about to castle as white. So this should not be allowed. So we say move piece, e1, so the castling is e1 to g1, that would be a castle. Normally it would be allowed, but it should be, oh actually the way that we say it, it was nil. Okay. Okay, undefined method pieces for nil class, move piece. Okay, an equal. Okay, so position, new, let's see where it is. It says 137, 137. Oh, okay. Okay. Other pieces each. Hmm. Hmm. This is interesting. Oh, let's take a look. Oh, it says oh, we're comparing against nil, and oh, I see. So the first thing that we should do is to check. So for the class. So if the classes are different, if self.class does not equal other.class, then we're going to just return false. Okay, and so this way we don't have to do this. So we need that condition in order for this to work. Okay, so let's save it. Okay, all right. So this is this is what we expected, that it allowed the castling because we got a position back, but we expected a nil. All right, so let's put the condition back in there. Not condition, the test for the castling. And that was for move piece. Okay, so we're at move piece. Okay, so this is where we're going to handle this. So let's think about this. So we already know that it's a king and we're about to castle. So it all depends on the 2 square and the turn. So 2 is equal to the G1 or G8. Then we want to check the K. Okay, so then let's write the code for this. So so this if 2 is equal to G1, so actually we would say white based on a turn, it's G1 or G8. And so you're going to castle, but castling does not include, and now we say, depending on what color you are, it's either going to be a K or a lowercase k. This needs a question mark. Okay, so this is saying if you're allowed to castle. Okay, so if you're going to castle but you're not allowed to castle, then we want to return false. Actually, return nil, because that's how we're doing this here, returning nil. Okay, and we also have the corresponding one, so we can actually put this here since it's just one statement. We're going to return nil if 2 is equal to the other side, which is on C1, and the castling is not allowed. Does not include, based on a turn, capital Q or lowercase q. All right, so let's see this. So we're doing a test, and we're going to return nil if you're trying to castle in one of the directions and it's not allowed. Okay, so let's see if that fixes the problem. Okay, so this is a so now we have a valid chess program, and it's able to choose possible moves. So I think it'd be fun to write a little program to just play a game, and the computer will just pick a random move. So let's write that as a first step. We don't really need to write a test for this because we're just going to loop through and use these functions. So there's a warning here. Syntax error. Let's see why. I'm going to save this. It runs, but it thinks that there's a syntax error here. Oh, it says shadowing outer local variable from. Oh, so we have a from here. That's true. So let's call this piece from. Okay. All right, so the syntax error message is gone. And let's take a look here. Trailing on, I see in the lower right-hand corner it says trailing on 80. So let's go to 80. 80 is right here. Yeah, we have an empty, like we have a space there. Okay, so it looks all clean now. All right, so let's write a little chess program. We have all the tools we need, so um, I'm just going to get out. So this way we start up with the, we'll just call it game.rb. Okay, so require lib chess, and let's try something simple. So we have a position. We start a new one, and we get an input. So while okay, so we get a line, and we get some moves. So let's see, position, move, str. All right, so, and then we'll print it out. So put s position followed by the move, so str. Okay. All right, so let's just see this right now. Right now the computer's not going to be playing, but let's just see if this works. So Ruby game. Okay, so it's I should actually print out the board when I first start, so let's do that. So put s position. Okay. And okay. Oh, we have all that extra debugging information. Let's just clear that out. Lib chess. Let's go to 2s. Actually 2s. And let's, so we don't need this debugging thing anymore here. And for this, we'll keep this. So let's just run it. All right, so it's white's turn, and oh, actually, there's like a extra curly brace. Okay. All right, so I'll say E4. Oh, invalid move. Undefined method xy_diff. Okay, for p. Okay, so this is in chess 166. Okay, so let's see why this, and it's xy_diff. Okay. All right, so we're actually we're already here, 166. So it's here. Actually, no, it's at, it was move piece, but then 29. Okay, symbol xy_diff. Oh, that's because this as well, this needs to include chess helper as well. So let's just include chess helper. Okay, and see if there's any other classes that might need it. Probably not. Okay, so let's see. So E4. So we can actually see here that, I'm going to zoom in here a little bit. You can see that it actually made a move. So, and then E5 would, I'm making a move for black. Knight F3. Okay, so let's have the computer choose a random move. So going back to this, we have okay, so let's say the possible moves for the position. Actually, okay. Oh, actually, another thing is that this game doesn't know about checkmate, so we have to teach it how to do a checkmate. But first, let's see it actually play a game, and we'll probably start teaching about checkmates and stalemates in the next session, and we'll start using start making the graphical interface But for now, we can see that we pretty much have everything that we need. We also need to put a little bit of brain into this chess engine. Okay, so position possible moves, sample. What sample does is, if I have a list of numbers and I just say sample, it'll pick a random number out of a random element out of it. So it's just going to pick a random move, and I'm going to say, okay, so this is going, okay, so move, and actually I shouldn't say move because move is a name of a method for position, but actually that's only if I say position. So okay, so position, move piece. Let me just make this look more like a variable. So M0 and M1. So the first element will be, actually, if I'm going to do it that way, then I might as well from and to. Okay, from to. Okay, and it'll also print out the position. And actually, we haven't actually figured out how to write the output of from and to. So instead, what I'll do is I'll just write the coordinates of it. So from to square and to square. Okay, so it'll tell you where it went to and from. Okay, so okay, so now we're going to actually play this game, and the computer is going to pick a random move out of the possible moves. So let's just play a few moves, and then we'll end this session. So okay, I play e4, and the computer played h5. I mean a5. A7 to a5. Okay, so I'm going to do knight f3. Okay, and it said it was an illegal move. It threw an illegal move on me. Let's see why. Oh, the reason is because um, it still thinks that it's black's move. Okay, so we need to, because move piece actually moves the it does the mechanics of it, but it doesn't do the rest of the checks and updates the turn. So we do need to do a move, and we'll pass it a string that'll look like from to. So we'll give it a new notation. It'll be from to with a dash in there. Okay, so this I'm expecting this to throw an error. So if I do e4, it'll throw an error, and it says it doesn't know b7 to b6, but at least we have that information, and we just need to modify the chess program so that let's go to move, and it doesn't match any of these patterns. So I'll just put an else if in here. Actually, I'll put an else if at the end of this. So it matches, let's see, A through H, 1 through 8, with a dash, A through H, and 1 through 8. Okay, so we have the from. Actually, we don't give it the from. We give it the list, and it's going to be $1 to index. That's the from. Oh. the piece, do I need to specify the piece? Yes, I do. So the piece is going to be whatever was on, let me just, it'll be overwritten anyway. So from is equal to $1 to index, and just say from over here. And piece is whatever's on the from. Actually, the way to be more consistent, we've been using self, so self from. So whatever's there. All right, so what else do we need? We need the 2. The 2 is the second argument to IDX. Okay, so we have the, okay, so this looks good. All right, so let's do this. Save it, run it. E4. Oh, it works. Now it's waiting for me to make a new move. I'm going to take that, so I'm going to say E takes F5. Okay, I took the pawn, made another move. I'm going to zoom in so that we can see this a little bit better. Okay, so I'm going to bring out my knight, knight F3, pushing the pawn, and I could do bishop takes B5, pushing the pawn. So this is not a very good program. So queen to E2, and he brought the knight out. Let's see if it knows how to castle. I said castle, but didn't like that. Interesting. So there seems to be a little bit of a problem here. Okay, I'm gonna quit out of this and try to see what happened here. Okay, so let's go back here. So it's white's turn. I did E4, that was fine. It's white's turn, that's my turn again. I did E takes F5, and that's fine. Okay, so it's white's turn, and I type something in. It's white's turn, I type something in. It's white's turn, I type queen E2. And this is the point where it kind of bombed. I typed in castle. Oh, this is interesting. Instead of printing out where it's printing out the previous move. Okay, so the output is a little bit off. But it didn't castle. So I told it to castle, but it didn't castle. And it didn't throw an error either. Okay, so let me try to run this again. And I'm just going to try to castle as soon as I can. E4, knight F3, bishop C4. I typed knight F4, C4. Okay, so E4, knight F3, bishop C4, and then castle. And it didn't castle. Oh, that's right. The reason why is because, okay, that's not how I wrote. It's only expecting the regular notation, not the algebraic notation. So, is that right? No, that's wrong. It should have recognized the castle. So let's see what's going on here now. Okay, so Oh, I see. I think okay. Castle should have been recognized over here, and um, all right. I'm gonna put a debugger on the castle. So let's take a look. So e4, knight f3, bishop c4, and then I castle. Okay, great. So it's in the right place. And then piece. Okay. Okay, list. Okay. So far, so good. Okay, so let's take a look at the list. Okay, 60. P 62 square. That's E1. Okay, that's the from. Let's print out the 2. Oh, this is incorrect. It's trying to castle on the wrong side. Interesting. 2. Okay, so I typed in this, but it got assigned to this. So that means that the string wasn't equal to this. Oh, I think the reason why is maybe because of the carriage return. I think. So I think because of the carriage return, it may be screwing things up. Okay, let's take a look. So we'll just run this again. Um, okay, this might be an input problem. So e4, knight f3, bishop c4, and castle. Okay, let's take a look at print stir.inspect. Yes, there's a carriage return at the end. So we need to chomp that. So that's causing some problems. So let's go back to our input. When we do a getS, we'll just do a chomp. So get rid of that carriage return. All right, so let's see if this will fix the problem. Okay, so e4, knight f3, bishop c4. Oh, no, continue. And castle. So it worked. So this is I'll end this right here, and next time we'll do a very simple algorithm to have the chess program figure out a fairly decent move. It can't find the best move, an unbeatable move, because chess hasn't been solved yet. So uh, we'll try to come up with a heuristic to come up with some good moves, and we'll create a user interface so that we can actually play with this without having to type in the information, and also handle the illegal move exception, because right now if it hits an illegal move, instead of giving you a warning, it just exits the program. So we'll do that all in future episodes. So see you next time.